Hi guys, my name is Soraya Luthra from the CJ Period 6 Physics Honors class, and today I'll be solving out problem 71 on page 54 for you. So, here's the problem. A photographer in a helicopter, ascending vertically at a constant rate of 12.5 meters a second, accidentally dropped the camera out of a window when the helicopter is 60 meters above the ground. Here are the two questions. A. How long will the camera take to reach the ground? And B. What will its speed be when it hits? Okay, since we know our problem, we can now sketch it out. So we have a photographer in a helicopter. The helicopter is approximately 60 meters off the ground and is going up at 12.5 meters a second. When suddenly the photographer drops his camera. Now that we have our diagram set up, we should look at our givens. Since it's a FreeFall problem, we know that the camera will be accelerating in a downwards motion at 9.8 meters a second. This value is also known as c. From our problem, we also know that the starting height of the camera is 600 meters. We can also know that the initial velocity of the camera is 12.5 meters a second. From our diagram, we also know that the final position of the camera will be 0 meters. So now on to actually solving out the problem. Part A asks us to find how long the camera will take to hit the ground. To do this, we must use our FreeFall equation, y equals 1/2 vt squared plus v naught t plus initial position. To solve for t, we must use the quadratic formula. After using the quadratic formula, we get t equals negative v naught plus or minus square root of v naught squared minus 4 times 1/2 v times initial starting position all over g. By plugging in our givens, we get t equals negative 2.4 seconds or 5 seconds. Since we know that time can't be negative, we know that the time that the camera takes to hit the ground will be 5 seconds. Now on to part B. Part B asks, what will the speed of the camera be when it hits the ground? Part B is a much more simple question than part A. To solve part B, we must use our equation velocity equals initial velocity plus acceleration times time. Now all we have to do is plug in our given values. We know that our initial velocity is 12 meters a second. Ooh, my bad. 12.5 meters a second. And we know that our acceleration is going to be negative 9.8 meters a second squared. Also, we know that our time, as solved in part A, is going to be 5 seconds. After plugging in the above equation into our calculator, we get that the final velocity of the camera before it hits the ground is going to be negative 36.5 meters a second. Alright guys, thank you for listening to my solution of problem 71 on page 54. I hope it helped.